Summer Packet video examples. The following examples are for order of operations. Order of operations, we follow the order of PEMDAS when we are simplifying. PEMDAS, P is for, tells us to do everything in the parentheses first. Parentheses, then exponents, then multiplication and division, and then addition and subtraction. So here are some examples. Example 1. There are no parentheses, but so we move to exponents. There's an exponent on the 4, not the negative, but the 4. So there's a minus in front of this. So this is just 4 squared, which is 16. Put the negative on it. Just going to copy down the rest. Next step is to take care of multiplication and division going from left to right. So the first thing I see is the division here. 24 divided by 3 is 8. Eight times 2 is 16. Now I take care of addition and subtraction. Negative 16 and 16 is 0. And this is the work that you should have shown for this problem as well. For example 2, there's actually 2 sets of parentheses. There's this set and this set. So the first thing I'm going to do is this set of parentheses, which is 3. Within the next set of parentheses, I have to repeat the order of operations. There are no other parentheses in here. Well, there are, but no operation to do in it. There is an exponent. 3 squared is 9. (25 minus 9 is 16. And 4 times 16 is 64. Example 3, where x equals 7, we're doing this expression and we have to simplify it. 21 minus 2 times 7, so I put that in parentheses, plus 8 divided by 4. Order of operations tells me to do parentheses first. Well, there's nothing to do in the parentheses. Then exponents. There are no exponents. Multiplication and division from left to right. So this becomes 21 minus 14. This becomes 2. And then addition and subtraction from left to right. 21 minus 14 is 7. Plus 2 is 9. Example 4, the difference between the opposite of 3 squared and negative 3 squared. In this case, I have the opposite of 3 squared. The squared is only on the 3. So I'm supposed to do 3 times 3, which is 9, and then put the opposite sign on it. In this case, I have the opposite of 3 squared, which is negative 3 times negative 3, which is positive 9. Now, we also need to be able to check these in our calculator. When I go back to example 1, either with a graphing calculator, which you'll use a lot in high school, TI-84 is what we recommend, or if you have a regular scientific calculator, it should be able to do order of operations. You can check your answers by plugging in it exactly as you see. Negative 4 squared plus 24 divided by 3 times 2 is 0. 4 times 25 minus, and another set of parentheses, 5 minus 2. Close those parentheses, square it, close the larger parentheses. 64, which is what we got. For example 3, 21 minus 2, whenever we plug it in, just like we wrote here with parentheses and plugged in the 7, we're going to do the same thing in the calculator. 21 minus 2 times 7 plus 8 divided by 4 is 9. And again, when you're plugging in a number, it's important to put it in parentheses. Here's why. A lot of times students will put in negative 3 squared when they actually meant to put in the opposite of 3 squared. They give you opposite answers. So be careful how you're plugging them in. We should be able to check all of these problems by plugging them into your calculator. Examples 5 and 6, we have to be very careful when we do fractions. We need to simplify the numerator and the denominator separately and then do the division. So for this, in my numerator, my exponent, I don't have any parentheses, but I have an exponent on the 2. 2 to the 4th is, I believe, 32. 2 times 2, nope, 16, sorry. 2 to the cubed is 8. So negative 22 minus 16 is our numerator. Negative 22 minus 16 is negative 38. So there's my numerator. 5 minus 3 is 2. Negative 38 divided by 2 is negative 19. Now, if you're going to plug this into your calculator, you have to use parentheses to tell the calculator to do the numerator separately from the denominator. So my numerator goes into its own set of parentheses, and my denominator goes into its own set of parentheses, and we get the same answer. Example 6. In my numerator, I have negative 8 squared, which is 64. So this is 5 plus 2 times 64. 2 times 64 is 128. So this is 5 plus 128. And 5 plus 128 is 133. In our denominator, we have the opposite of 2 cubed, which will be the opposite of 8 minus 3, which is negative 11. 133 divided by negative 11 cannot be reduced. So you can leave it as that, as an exact value in fraction form. The decimal approximation is negative 12.09, or negative 12.09 repeated for an exact. So let's again look at how to do this in the calculator. We have 5 plus 2 times negative 8 cubed, close parentheses on the numerator, divided by negative 2 to the third minus 3, close parentheses on the denominator. And when I feel like I did something wrong here, hold on. When I convert it back to a fraction, it's much larger. Let's take a look. 5 plus 2, oh, I did negative 8 cubed, and it was supposed to be squared. Hold on. Negative 8 should have been squared. It was the negative 2 that was cubed. There we go. There's the right answer. Negative 12.09. If I convert it back to a fraction, negative 133 over 11. This concludes the examples for order of operations. There are similar examples in YouTube videos and in the online algebra textbook.